Hey everyone, welcome back to my channel. Let's talk about what is the difference between Newton's first law and Newton's third law. For Newton, first law states that if an object is at rest, and if an object is in motion, it will stay in motion with the same speed and direction unless acted upon by a net external force. What this means is that if an object is at rest, it will remain at rest, or if it's moving with a constant velocity, it will continue to do so unless a net external force acts on it. For example, suppose we have a ball sitting at rest on a table. There are several forces acting on the ball, including the force of gravity pulling it downwards and the normal force from the table pushing it upwards. However, since these forces are equal in magnitude and opposite in direction, they cancel each other out and the ball remains at rest. Now let's say we roll a ball across the table. Again, there are multiple forces acting on the ball, including the applied force from our hand, the force of friction from the table, and gravity. However, as long as the net force acting on the ball is zero, the ball will continue to move with constant velocity. This is Newton's first law of motion. In contrast, Newton's third law states that for every action, there is an equal and opposite reaction. It tells us that whenever one object exerts a force on a second object, the second object simultaneously exerts a force equal in magnitude and opposite in direction on the first object. So when we push against a wall, the wall pushes back on our hand with an equal force. When we walk, we push the ground backwards with our feet, and the ground pushes us forward with an equal and opposite force. Newton's third law applies to all interactions between objects, regardless of whether or not they are in motion. Here's an example of Newton's third law in action. Imagine a rocket taking off into space. As the rocket expels gas out of its engines, it exerts a force on the gas. According to Newton's third law, the gas must exert an equal and opposite force on the rocket. This force is what propels the rocket upward. Without this reaction force from the gas, the rocket would have no way to move. To Newton's third law is a fundamental principle in physics that helps us understand how objects interact with each other. So what is the difference between Newton's first law and Newton's third law? Well, Newton's first law states that an object at rest stays at rest and an object in motion stays in motion with the same speed and direction unless acted upon by a net external force. In other words, it describes the tendency of objects to resist changes in their state of motion. On the other hand, Newton's third law states that for every action, there is an equal and opposite reaction. It describes the interaction between two objects and how they affect each other through forces. Newton's first law can be observed when a book is resting on a table. If the book is not moved, it will remain at rest. This is because the force of gravity pulling the book down is balanced by the normal force from the table pushing the book up. Since the net force on the book is zero, it remains at rest. Similarly, if the book is sliding on the table, it will continue to slide with constant velocity. Since the frictional force opposing the motion is equal and opposite to the applied force. On the other hand, Newton's third law can be observed when two billiard balls collide. When one billiard ball strikes another, the force of impact from the first ball on the second ball is equal, and opposite to the force of impact from the second ball on the first ball. This is why the balls exchange momentum during the collision. It's important to note that Newton's first law only applies to the motion of objects within a frame of reference. For example, if we were to observe the motion of a book on a train that is moving along a straight track, the book would appear to be at rest relative to the train. However, from the perspective of someone standing on the ground, the book is actually in motion. Therefore, according to Newton's first law, the book would not remain at rest, but would continue to move forward with the same velocity as the train. In contrast, Newton's third law is an interaction law, which means that it applies to the interaction between two or more objects regardless of the frame of reference. For example, the force of gravity between the Earth and the Moon is always attractive and equal in magnitude, regardless of whether we are observing it from the Earth, the Moon, or any other frame of reference. To summarize, Newton's first law deals with the tendency of objects to resist changes in their state of motion, whereas Newton's third law deals with the interaction between objects through forces. Newton's first law is an inertial law, which means it applies to objects at rest or in uniform motion. In contrast, Newton's third law is an interaction law that applies to all objects regardless of their state of motion. Another key difference between Newton's first and third laws is that Newton's first law is a single law that can be applied to individual objects, whereas Newton's third law is a pair of laws that apply to the interaction between two objects. For example, when a book is at rest on a table, Newton's first law states that it will remain at rest because the net force on the book is 0. In contrast, when two billiard balls collide, Newton's third law states that the force of impact from one ball on the other is equal and opposite. There is no single law that can describe both of these scenarios. Newton's first and third laws are interconnected in the sense that Newton's third law provides the basis for understanding the forces that act on an object. By knowing the force that one object exerts on another, we can determine the force that the second object exerts back on the first. This allows us to calculate the net force on an object, which in turn allows us to predict how the object will move according to Newton's first law. Overall, Newton's first and third laws are fundamental principles in physics that help us understand the motion of objects and how they interact with each other. While they are distinct laws with different applications, they are interconnected and provide a comprehensive framework for analyzing mechanical systems. Alright guys, now I want to give you a little bit of a challenge question to think about. Newton's third law states that if there is action, then there will be opposite and equal reaction. What is missing in this statement? What is one thing that you need to be mindful of while applying this law? Leave your answers in the comment section below. And make sure to click on the subscribe button to get notified when we post new videos. Thank you very much for watching, and we will see you in the next video. Take care.